Welcome to today's webinar, Getting Started with AWS IoT. Our presenter today is Daniel Austin. Today with us, we also have Asaf and Alex. They are our webinar moderators who will be engaging with you and answering your questions throughout the presentation. Daniel, welcome. The floor is now yours.
Hello, everyone. Thank you for being here. There are 300 plus people in the webinar today, and I'm very excited to have you all here. We'll be talking today about the AWS IoT service. I'm going to talk to you about some of the customers that are using it currently. I'm going to talk about how the service works and the different features of it. Feel free to ask questions at any time. We have a couple of my colleagues are moderating, and they're free to answer questions, and they'll be assigning some of those to me as we go forward. But I won't be able to answer those until we get to the end, and I'll try and leave some end for Q&A. The slides I think everyone can see on the screen, so I'm just going to go ahead and get started. So the first thing I'd like to do is introduce you to some customers that are currently using our IoT service. Just a bit of history here. Our IoT service was launched last year in 2015 or 2016, and has been, in true AWS fashion, we've been iterating over it ever since and adding new features. The presentation today will hopefully cover all of the new features of the service, and we'll also be talking a little bit about a new AWS service called Greengrass, which will come up in later slides. But first, let's look at what some of the customers are doing currently with AWS.
Which is a company that is involved in agriculture and making sprinkler systems. And they're using AWS IoT to gather the data that you would expect from such a system, soil temperatures and sun exposure, this sort of thing. They actually are using our AWS Lambda product to get that information and displaying it on people's phones and desktops. It's a very good experience that they've hooked up to some of our business intelligence tools internally to get the displays like you see there. The next company that I wanted to talk about was Philips, and Philips, of course, is a very, very large company, but in this case we're just talking about the healthcare industry and their healthcare vertical, and they have something like 7 million connected sensors, and that's a very large number. All of those are feeding data into our AWS IoT service, which then goes into a data store and they do a lot of analysis on that. It's a very large data set, 15 petabytes of patient data. So this is a very, very large scale AWS IoT engagement, and maybe this may be at the very largest levels of people using our IoT service. I don't know of anybody that's working on anything larger than that except possibly some of the utilities. The next customer I wanted to introduce to you is sort of near and dear to my own heart, which is the Sonos company, and they make wireless speakers for people's homes, and I personally have a number of Sonos speakers and use this system regularly. With our IoT product, what they've done is hook it into their client on the mobile devices, the phone and the iPad devices like this. And when you choose to play a song or an album or access a music service, they collect and store all of that metric data. And some of the data is very interesting that they're gathering. For instance, they have this TruePlay product, which will actually help you tune your speakers. So it's a little app on your phone, and you turn it on, play music through the system, and it tries to optimize your experience with that speaker. And so there yet another example of people using our IoT service to build very large customer-facing systems. And my goal here with these slides and sort of explaining these companies' usage and use cases is to give you the idea that this is not a small minimum viable product service offering from Amazon, but really a fully featured product in this IoT space. And so Sonos, once again, one of my favorites and works extremely well, backed by AWS IoT. The last company profile that I wanted to talk about here was the British Gas Company. And of course, we're familiar with them. They have some business here in the U.S. as well. But they're basically doing a connected home strategy with AWS IoT, and people can remotely monitor the amount of heating and their hot water and so forth in their homes and use that information to sort of optimize their spend with British Gas and make sure that their utilities are going forward. And so far they've only got about 75,000 customers, which compared to the Philips use case we saw previously is actually fairly small. But they're doing some really interesting work with the gas company, and they're also looking at the possibility of using it for gas exploration in the field as well, and being able to monitor those energy sources in the field as well as the end destination in the user's home. So the goal here is to give you the idea that there are several large companies that are using this. They're customer facing. They have several large scale engagements with us. And AWS IoT is meeting their needs and in many cases exceeding what they have asked for and providing additional features. The Dropcam is maybe the last company that I want to talk about here, and I think that most people have some experience with Dropcam, but with their IoT service, they're trying to expand their capacity through AWS auto scaling as they bring in computer vision data and try to identify objects in photographs, similar to the AWS recognition service that we just announced. The thing about Dropcam is that they have a large amount of data coming in very quickly. And the way that they're delivering their data into S3 and then using the system to analyze it for computer vision purposes is very interesting. But for our purpose, it's sufficient to say that they have this data coming in that they need to react to within a 10-second period. And by using AWS IoT and several of the other services, as you can sort of see in the diagram there, they're able to meet that requirement, analyze the data, and get their computer vision applications working on behalf of users. So I was just looking to see if people are asking questions yet, because we're going to go into the next section of the talk. Now we sort of reviewed some customers and their use cases. Let's dig a little bit into how the AWS IoT service actually works, and look at also the Greengrass product offering, which was just announced at our reInvent conference in November. So just to give you an idea of the things that AWS IoT addresses, we're using alternate protocols in the form of MQTT and WebSockets. As far as scalability, security, and management go, this is an AWS managed service. So we take care of the scaling of the system for you. We make sure that it continues to run and meet its availability SLAs. And so a lot of the scalability, security, and management part of it is on us. The integration with cloud and mobile applications, primarily this is done through the AWS Cognito product, which is designed to provide authorization for users on mobile devices and household devices, things like Alexa. And of course we also have a lot of SDKs and tools out there for you to write systems of your own. And those tools are available, I think, in Java, JavaScript. I'm trying to think of some of the others. I know there's a Python SDK, several languages that we support through our SDK and toolkits. Just digging in a little bit on the AWS IoT service itself. The AWS IoT service itself basically has 6 individual modules or components in it. We'll sort of go over those in the next few slides, but I wanted to call out a little bit about the security of the system. One of the things that people always want to know about with respect to AWS IoT or IoT in general is the overall security of the system and how that data is protected both in transit from the things or the devices to AWS, and then how it's stored within the AWS system. So we have different solutions for security in motion and security in rest. For security in motion, any connection to the MQTT Broker, which is one of those components of the AWS IoT service, takes place over TLS or SSL as we normally call it, and has the same level of security as when you go to a website with an HTTPS URL and you're using an X509 certificate to secure that connection, which is encrypted. The only difference here with AWS IoT and the normal connections that you would make to Facebook or Google over an HTTPS URL is that for IoT, we use what we call TLS mutual authentication, and this requires that both devices on either end of the communication stream exchange certificates. On the web, the normal course of events is that only the site that you visit, Facebook or Amazon or whatever, offers your browser a certificate to ensure that the browser knows that the website is the one that they thought it was. For IoT, the client also has a certificate which has to be sent back to the server in order to tell the server that this client is authorized to talk to that broker. So it's a mutual authentication with SSL rather than a single leg of authentication as we normally see for websites. On the business logic front, we have the real heart and brains of the IoT service is the rule engine. And we'll talk more in depth about the rule engine as we go forward. But the rules engine basically allows you to run SQL or SQL-like statements against the data coming in over MQTT to the broker, and then take action based on the results of that query. So we'll see examples of this later, but you can, for instance, select all of the incoming data that has temperatures, for instance, and treat those differently. Or you could have the rules engine react to a notification. For instance, if a machine goes down or a thing has a problem, it can send a message to the MQTT broker. The rules engine will recognize that message as a cry for help and take some action to respond to it. And we'll see more examples of that. The other things that I wanted to talk about is the interaction with mobile and mobile devices. So we've really set IoT up so that it's accessible to from mobile devices, and one of the main ways we've done this is that in addition to the MQTT protocol that we support for the AWS IoT broker, we also support WebSockets. And the WebSocket protocol, I think, is supported by all of the mobile browsers, and so you can hook up to AWS IoT in two different ways, via MQTT or via HTTP over WebSockets. And in both cases, that's a secure connection, and we're using the TLS mutual authentication scheme. Digging down into the internals of the service, let's talk about the individual components that we have here. So the first one is the message broker, and I talked about this a little bit earlier. This is a pub/sub message broker, implements the MQTT protocol. MQTT is a very simple, lightweight online protocol that was really designed for IoT purposes. For practical purposes, the messages that are going back and forth on the IoT platform at AWS are JSON messages. You can use other formats with the AWS IoT platform if you want to send things in binary, ASN1 or whatever you want to send, but the underlying fundamental language for the IoT platform is JSON, and most of the messages are in JSON going in both directions. The message broker is a full-fledged MQTT broker. It supports all of the various functions of the MQTT protocol, with one exception, which is that we do not support a quality of service level greater than 0. And I wanted to call that out because it's one of the questions that I get from users about the MQTT broker quite often. So we do not support QoS of a message greater than 0 at this time. And that means that the broker will only retain that message and deliver it in a specific set of circumstances. And you can dig in more on the MQTT protocol to find out more about that, but essentially quality of service level 0 says that the broker will deliver the message at least once to the next client that's subscribed to that message, but no more. And the data will not be retained past that point. QoS levels 1 and 2 provide additional data delivery for MQTT, but like I said, not implemented yet. The MQTT broker otherwise is very straightforward. It operates on port 8883 because it's using SSL, or mutual TLS, as we said earlier. And MQTT is basically a pub-sub protocol. You subscribe to a certain set of topics. A topic is just a destination. And after subscribing to that destination, any messages that are sent to that topic will be received by the subscriber. And so one person will publish something on the topic and all of the subscribers will then receive that message. And obviously there can be many subscribers to an individual topic and many devices that publish on that topic as well. The names of the topics are very important, and we'll get into that a little bit more when we talk about the shadow mechanism. But the topics are essentially look like paths on a file system. They're sequences of characters separated by a slash character, much like a path on a file system. And you can use the semantics of the topics to sort of specify what is the actual payload that's being sent to that topic, the actual message that you want to send to your subscribers, and provide a way to use those topics so that, for instance, if you have a real-time notification of an emergency or a problem with a system, you could respond to that by sending a message to the system status emergency topic, if that's what you chose, just to choose an example there. So that's basically the message broker. We'll get into some of the aspects of MQTT and how it's specialized for AWS IoT as we get into the next component, which is the rules engine. And you can sort of see the rules engine here in the center of the diagram. Basically, when a message is received by the gateway or the message broker, it's passed to the rules engine, and the rules engine applies in sequence a set of rules, and we'll look at what those look like here in a minute. But they're essentially SQL-like statements that are applied to that topic as if the topic were itself a data source. So if you're used to accessing a database, in this case, the rules engine sort of treats a topic as if it was a table. And so you query the data that's coming in over that topic. For instance, if we have a topic slash device ID slash temperature, and then we send some data along that containing the temperature, the rules engine can be set up to have a rule that says, I see that this is a message on the temperature topic. I'm going to take it and direct it over to Amazon DynamoDB and store that data in a specific data table reserved for temperatures. So the rules engine, its actions are really designed to analyze that incoming data on each topic, apply any rules that are found that apply, and generally direct that data to its final destination, whether that's being stored in a database or whether the data is being sent to some second-level AWS service such as Amazon Kinesis or Elasticsearch most of the Amazon services can be hooked up to the rules engine, and in particular, the messaging services like SNS and the queuing services like SQS you can send data from the rules engine to those services. Obviously, you can fire a Lambda function and send the data from that topic, the payload, to the Lambda function for further processing. There, you can hook up to DynamoDB. There's also some ability to send your data to Amazon QuickSight, which is a relatively new service that we announced at the end of last year. And QuickSight provides easy visualization for your data. So you can send your data from the IoT broker directly to QuickSight, and then QuickSight can quickly show you a graph or display of that data as it's coming in. So the rules engine's job is really to process that incoming information and send it off to the next spot. And it's really a dispatcher design pattern around the rules engine. The thing registry is the component that I want to talk about next. It's really very simple. Obviously, if you have one thing, it's relatively easy to keep track of that one thing. But when you have 1,000 or 100,000 things, it's much more complex. And the registry, the thing registry module, is really intended to help with that. So every device that comes in can register with the thing registry and store some information, attributes about itself, so that it can be identified and tracked in the future. And the registry itself is relatively short on features. It's not heavily overloaded on features, but it has all of the things that you really want, you know, adding, updating, creating, and deleting the entries in that registry. And it's really very simple mechanism and not terribly different from just a simple database table. The next part of the IoT service I want to talk about is actually a little bit more complicated, and this is the shadow service. And so it's sort of illustrated on this picture here where my mouse is, but the picture is not very enlightening, so you won't get much out of that. But let me try and take a stab at explaining what the device shadow mechanism does. In the world of IoT and small client devices that we're talking about, things, sensors and these sort of things, it's just not the case that these devices are connected to the network at all times. In many cases, these devices can't really even support a TCP/IP connection and connect to the internet at all. In other cases, even if those devices can support if those devices can support the TCP connection, they aren't able to be online at all time. Think about things like an automobile that's traveling on the road. At some point you may be able to get an internet connection, and then you go through a tunnel and you're disconnected. All devices go through some period of intermittent connections, and the device shadow is really there to handle those cases. We've created a special set of topics within the IoT broker that are associated with the device shadow, and these can help you set the desired state of your device. So let me give an example here of a light bulb. If you have a light bulb that's provisioned as a thing on AWS IoT, let's say that it's on, but the controlling device that has the switch for that lamp suddenly goes offline. There's a storm, for whatever reason that device is offline. If you go and send a command to turn that light bulb off, that command will not reach the device because it's not online right now. The device shadow can actually store the desired future state of that device and apply it the next time that device comes online. So for instance, let's say our light bulb is on and you want to turn it off. You send that command. The light bulb unfortunately isn't online right at this exact moment. The IoT service will store that as part of the device shadow. When that device comes in, it will immediately be sent that change of state request, and the light bulb will be turned off. So the device shadow really provides you with a way to provide forward-looking commands for cases where your devices are only online intermittently. And I know that that explanation could have maybe could have been more concise, but if there's questions about that, please put them into the question here in the chat, and we will try and answer them. But just to try and sum up on the device shadow, this is a way for us to do store and forward on messages that are not connected at all times in order to provide some information about the desired state of that device. And the only other thing that I want to talk about here, and I notice that people are talking about the slides not advancing, and that's because I'm staying here on this IoT platform slide for the moment. It's not intended to be advanced just yet. But just one more note on this particular topic I wanted to call out is that the pricing around the AWS IoT is around $5 per million messages. And I'm going to advance to the next slide now, getting into the MQTT protocol a little bit. The slide here says that we do support QoS 1, and I'm here to tell you that that is not correct as of yet. We are planning on support for that, but that support is not there yet. So we only have QoS 0 support. Obviously, HTTPS and WebSockets is an alternate way. The various different languages that we support are listed here. Embedded C was one that I forgot to mention earlier. And there's an Apache SDK out there that you can also use. The Payho client originally from IBM works just as well. I don't want to belabor this part about pub sub routing too much, but this is basically the overview for the message broker. Back to the topic of security, like I said earlier, we've got the certificate exchange on both sides, both the device and the broker will exchange certificates. That means that everything has to have its own certificate, and generating that certificate and associating it with the right policies on the AWS service is one of the sort of the pain points about provisioning things. So we're working on various different ways in the next version to try and ease the pain around provisioning devices. But for the moment, you basically have to either use the console, the SDK, or the CLI to create a certificate for your thing and then load it onto that thing, and it has to be there in order for your client to connect. There are some devices that are being sold that have their own certificates to connect to AWS IoT pre-injected, and we'll take a look at one of those in just a few minutes. But essentially, the provisioning involves generating a certificate, associating a policy with it, and an entry in the thing registry, and making sure that that certificate is available to the client on the device. Obviously, it will try to connect to AWS IoT. The server will send its certificate so that the client can be sure it's connecting to the right place. The client sends its certificate to the server to, assure the server that it has the permissions to perform actions on the broker. I don't know how many of you are familiar with IAM, which is Amazon's Identity and Access Management Service. The IAM service is is the service we use to manage access to all of our services, and the AWS IoT is no exception to that. IAM works through the idea of roles and policies. Individual users will assume a specific role, and that role will have specific permissions to to carry out different tasks, such as connecting to the AWS IoT Broker, publishing on some topics, but perhaps not on others, subscribing to some topics, but perhaps not others. So you can get relatively fine-grained with the role-based access control, and you could set it up so that individual policies apply to different classes of devices. I see customers doing this so that they have some set of devices. These are usually hubs in some hub and spoke type architecture that are allowed full access to the IoT broker, whereas other classes of devices are only allowed read-only permission, for instance. So all of that access control for the system is basically handled through IAM and the mutual authentication with TLS, or SSL we often call it, although that's not quite correct. Just on the roadmap here on this particular thing, we're obviously developing more ways to onboard devices. We want to come up with easier ways to onboard large numbers of devices. If we had to provision 1,000 or 10,000 devices in the future, how would we scale that provisioning process? We're working on that. We're working on the ability to use OAuth as an authentication option. We want to allow you to use Amazon Certificate Management Service to manage your certificates for AWS IoT, which would add tremendously to the ability to manage, large numbers of certificates associated with things in the field. If you think about it, at some point those certificates have to be revoked or rotated or changed, and our certificate management service is sort of uniquely designed to help with that. So we'll be adding that feature to the AWS IoT Broker in the future. I can't tell you exactly when those features are going to come out, but this is sort of some of the things that are on our roadmap with respect to security and access control. So the device that you see here on the screen is a custom device from a company called, believe it or not, Microchip, and you can go to microchip.com and look it up. But this is a custom-made device that has the certificate already injected into the device, and it's already provisioned when you receive it. So you receive it and basically plug it in, and it takes care of all the certificates and authentication and authorization for you. You can basically plug it in, establish the connection via Wi-Fi. This is a Wi-Fi enabled device. You can see the antenna over here on the right-hand side. And once you have established that wireless connection, the device will be hooked up and will go through the steps to provision itself as a new thing on AWS. So there's a couple of these devices that are already provisioned, available for you. This particular one costs $250. It's more full-featured than some of the other devices that we're supporting out there, and so it has a little bit higher cost. But we have other boards similar to this that are in the same cost range as, say, Raspberry Pi or BeagleBone, some of the cheaper maker boards that you see in on sites like Adafruit and SparkFun and so forth. This kit from Microchip is not by any means the only one that is out there. It's just one of the ones that has the provisioning set up at the factory, I wanted to call attention to that zero-touch provisioning, because that's that makes your life much easier not to have to worry and pull your hair out about provisioning and managing the provisioning for the device. The one drawback for this device is that because this is a testing device, it's not necessarily terribly easy to rotate or invalidate the certificate that is on the device and was injected at the factory. So if that certificate is compromised in some way, that could cause a definite problem. These are early days problems that that Microchip and others will certainly be solving in the future, but I want to just put it in your heads to think about these features when you're thinking about buying these devices. Not only do you have to have a way to secure the device, but you have to have a way to change the certification and authorization credentials on the device. And you need to be able to do that without necessarily putting your hands on the device in the field. If you have to go out and do it manually, it will be very painful. So something to think about is, pardon me again, is how do you provision these devices and how can you rotate or change the certificate and the underlying authorization for the device. A little more in depth on the rules engine here. Some of the things that you can do are, so the SQL syntax is there at the top, and just like I said, it's sort of a pseudo SQL syntax where we treat topics as if it was a data source. There's a conditions clause where clauses and then take some actions on match. Like I said, one of the things the rules engine can do is allow you to connect easily to all the other services that are behind the scenes at Amazon. Kinesis, Dynamo, machine learning is actually a very popular one. The SQL language that the rules engine understands is actually a fairly rich set of primitives. There's the obvious math libraries. There's some JSON parsing. There's some macros and functions to deal with things like timestamps. You can get data about which topic the message was sent on. Various other things. I would encourage you, if you're using the rules engine in this way, to carefully scan those built-in functions that the rules engine understands, because it can save you a lot of trouble if there's a built-in, for instance, around parsing JSON entities and so forth. You can do a lot of that through the rules engine in a very clean and easy to implement way, whereas it might be difficult to do that in a more manual way. So I saw somebody asking about Lambda, and you can definitely trigger a Lambda from a rule in the rules engine, and send the payload for that message down to the Lambda function and have it do some further processing on that. It currently says that there's 10 AWS services that are available for data transfer from IoT, but I think that number is actually larger now. And I would have to check, but it's at least 10, but I think it's actually a few more than that now, just because we've added some products. I know that we've added the QuickSight product since then, and you can use that to analyze IoT data as an example. The payload, once again, is JSON. It's straight vanilla JSON. If you've ever used JSON schema, like if you go to jsonschema.org, you can use JSON schemas to define the payload formats, and I would encourage you to do that if you have a lot of devices that are sending similar messages. So let's take, for example, a case where a company has large numbers of thermometers out in the field. Let's say they have 10,000 thermometers. Sending that data back to AWS into the IoT broker really requires some rigor around what that payload format looks like. And in those cases, I'm recommending that customers use a JSON schema, define the JSON object that holds their temperature data in this case, and then ensure that their client sends that data in exactly that format every time. And what we're really doing here is using the schema to impose some order and consistency on the messages that we get from our devices. And that's definitely a best practice, and I would encourage you to look at jsonschema.org to get some ideas about how to define these messages for the IoT broker. Some of the roadmap items around this: custom select functions, API gateway integration is already there, I believe, and that's one of the things that we've added since these first 10 services were rolled out. And more payload type support. I know that I read just a few days ago that we've started to be able to support binary formats for the IoT broker messages. So I know that that binary format is supported as well. So, machine learning. One of the built-in functions in the SQL language supported by the rules engine is the predict function. And basically this hooks into Amazon machine learning, and the typical case is that you want to do a binary classification and determine whether some data falls into one class or another. The Amazon machine learning service basically works in, very similar to the way that all of these ML services work. You create a model, you train it with some existing data, and then based on the model and the training that it's undergone, the next incoming data point can be classified into, if it's a binary classification, into one of those two classes. We can obviously do a multiple classification as well, do a regression to predict the best fit line and get a numeric value for our prediction of the next value. Just to give you an idea, if we have, once again, a company that's fielded 10,000 temperature sensors over some area, they can use the machine learning model to predict what the values of the temperatures will be on those devices at some point in the at some time in the future. And basically the way that this will work on the IoT service, the data comes into the rules engine, is sent off to the machine learning model, where it's it's processed according to the model. And then you can take some further action on that model. For instance, if the temperature, and this is, there's a select statement down at the bottom of the slide that shows this. Basically, if the prediction is for a temperature greater than 150, then a lambda function will be triggered on the back end with some response to that condition. And this obviously assumes that there's a model that has already been trained and is ready to perform prediction on that data. You can't just call predict with your first data point and expect it to provide any prediction. You have to go through a model construction and training process. So the next thing I wanted to talk about was Elasticsearch, but before I did that, I wanted to correct myself on something that I said earlier, which was incorrect. We are now supporting the QoS level 1 for MQTT messages, and that's a correction to what I earlier said. Which I said we only supported QoS 0. We are now supporting QoS 1, and so slight correction there. Back to the slides talking about Elasticsearch integration. So Elasticsearch comes with a tool called Kibana, and Elasticsearch plus Kibana provide an easy way to do some quick and dirty business intelligence on the data coming in from AWS IoT, for instance. You can use the Elasticsearch service to quickly visualize and set up reports on your data. You can store the data in Elasticsearch, create an index over it, and perform complex queries. Give me all the sensors where the temperature was greater than 150 on Tuesday, or something, a complex search query like that. This works pretty well, and my team at AWS actually has developed an entire workshop based around AWS IoT and using Elasticsearch and Kibana for visualization. It's relatively fast and easy to set this up. It does have some drawbacks. There's limitations around what Elasticsearch can support, and there's limitations around what Kibana can provide in terms of visualization and reporting. In a lot of cases where Elasticsearch and Kibana don't provide sufficient power or capacity to really meet the user's needs, we're suggesting that they look at Amazon QuickSight service to do the visualization of the data. So, but that's really for cases where Elasticsearch and Kibana won't meet the need. In the general case, I've seen people have a lot of luck leveraging Kibana and really being able to quickly visualize what the data looks like. So that's Elasticsearch. The device shadows, and this is sort of what I was talking about earlier, right? This is a virtual representation in the cloud. We write what we want for the desired state to the shadow, and as soon as that device comes back online, we send that message to the device and carry out that action. And just as it says here on the slide, the shadow can hold that state for up to 1 year. So if your light bulb doesn't come on for 6 months or 9 months, the next time it comes up, within a year, it will receive a message from the shadow service telling it that its desired state is, changed to off. The shadow obviously has, REST APIs and so forth. You don't need to know anything really about what protocol the device is using, although under the covers it's MQTT, and we have a specific set of MQTT topics that we use to manage the shadows. All of those topics start with $AWS. So don't create any topic in your device that has a name that starts with $AWS, and there will be no collisions because that's how we do naming for our shadow topics. We're saying here 120 milliseconds round trip for the shadow, but actually, in my experience, it's considerably faster than that, maybe around half or 90 milliseconds. And pardon, has actually done quite well in all the tests, especially field tests that I've used it. Just to give you a glimpse on the NDA and the roadmap the roadmap on this. The roadmap for this is not under NDA any longer. I had intended to change that on the slides and did not get the chance. We're going to allow larger shadow documents, meaning that you can preserve more complex state. Obviously, we after 1 year, the state is set back to neutral, and no state in the shadow service is preserved for more than 1 year. And the group shadows are a way of applying a shadow to a large number of devices all at once, and that's going to be very important for the AWS Greengrass product, which is what I'm hoping to talk about in the next couple slides. Just real briefly on the metadata, again, we're preserving all of this metadata in the IoT registry, unlimited device entries in the registry, 50 attributes per thing, and some of the things that are coming up are top-level entities, grouping, policies on groups, group shadows, we saw that on the previous slide. Tagging, I believe, is already available, and searching on the device, and especially searching on the shadow state, so that you could determine at any given time what the shadow state actually is, which is currently not all that easy. It's not so easy to, if you've set the shadow for a specific device and it has entries, it's not necessarily obvious how you can actually understand from the console or the SDK point of view exactly what that shadow state is. So we're going to provide a search mechanism to fix that. There was a big console redesign. I'm not going to go through this in a lot of detail because you may never have seen the previous version, so the existing version is all you know. We did do a big redesign, and it works considerably better and considerably faster. Still some work to be done on this, and there's some roadmap items that we have planned for the console. And I'm going to skip the part about the dashboards because this is not radically different from other parts of the AWS system. The one thing I do want to say about dashboarding is that you can associate a dashboard with a certificate. If that certificate is uniquely associated with a device, this gives you an easy way to quickly create a dashboard for that device just by using its certificate. The pace of innovation for AWS IoT is crazy. As someone who tries to make IoT my area of depth within AWS, I'm continuously challenged to keep up with this. But just to give you an idea of some of the things that are coming out in the 2016-2017 time frame, all the things here on the left-hand side have already launched. The new region coming up for Frankfurt and Singapore, binary payload support, a number of other things that are coming up on the roadmap. The one thing I wanted to call attention to is the IoT at the edge, and we'll be talking about that with respect to Greengrass. The pricing, by the way, for the IoT service is free for the first 250,000 messages in a single year, and there's some enterprise discount programs and so forth that we can use to help with expenses for very large installations. But $5 per million messages in US East, that's North Virginia, ranging up to $8 per million in some of the Asian regions. So essentially very cheap. Although if you try to work out how much it would cost to transfer a gigabyte of data, you'll find it's about $10,000. The messages for MQTT are really short, and the metric of data volume is not a good metric here. The messages are generally on the order of 10 or 20 bytes. So let's talk a little bit about Greengrass. We only have about 5 minutes left, but I'm hoping to introduce the Greengrass product to you. So with Greengrass, Amazon has taken the IoT service a little step further, and we're providing a client software that runs on your client device. It has to be a device that can maintain a network connection, and this device basically is provisioned for AWS IoT. It manages all of the certificates and policies and so on for you. And essentially you can set up a hub on AWS IoT using Greengrass in very short order just by installing the software. And here on the slide it says most machine data never reaches the cloud. What we're trying to do with Greengrass is do some IoT processing at the edge where the client lives rather than sending every bit of data back to the Galactic Central and then processing it there. To do that, we had to deal with the laws of physics, economics, privacy and security laws, and we actually, let me get through this, this slide here. It's going to bring up some additional information. With Greengrass, we have moved some parts of the AWS broker out to the edge. There is a rules engine and a Lambda execution engine on the Greengrass client. This is on your device. And so, for instance, Greengrass runs on a Raspberry Pi, and that's one of the boards that it'll run on. And I have a Raspberry Pi running Greengrass that has several local Lambda functions installed local to that device. And the rules engine on the device will take the messages coming in from its clients and apply the rules to them. And if it can be executed locally via a local Lambda, it will be done that way. So we're basically moving that processing out to the edge, giving the IoT platform some brains, not just for communications. In the past, most clients have just been connected to IoT from a communications point of view, and all the processing was handled in the cloud. With Greengrass, we've really pushed that functionality out to the edge onto your device. At the bottom here of the slide, it points out it's not hardware. You have to bring your hardware and install Greengrass on it. Some of the features, like I said, we have local Lambda execution, which is amazingly helpful. Many of your messages will not need to be sent upstream when you can process them locally via Lambda. There's local device shadows that are tied to the context of that device. There's a local MQTT broker. So devices in your home, say you have Greengrass set up as a smart hub in your home, the devices in your home can use MQTT to talk to Greengrass, and then Greengrass can handle the communication to the AWS cloud. Those two things are separate. There are two separate MQTT channels in Greengrass. One is the local channel, one is the remote or the cloud channel. Also, we have local security applied to Greengrass in addition to the TLS mutual authentication. So some of the benefits here. Earlier we were talking about what happens if your device goes offline and you need to use the AWS Shadow service for this. You can manipulate those shadows locally on your Greengrass hub, and that will help ameliorate those situations where your device is offline. Obviously, you can respond quickly to local events that are happening and confine their processing to the context in which those events take place, rather than sending them upstream and waiting for a response. The simplified device programming. At this point, Greengrass and the Lambda execution service within Greengrass only supports Python and Node.js, essentially JavaScript. But we are planning on supporting the other languages that we support with the IoT SDKs for Greengrass, Java, embedded C, perhaps .NET, although I haven't heard anybody talking about .NET. And obviously, since none of the data from Greengrass is sent upstream and no processing is done upstream, well, I don't want to say that none of the data, but some of the data is processed locally. Let's try and go with that. Since some of that data is processed locally, it reduces your overall cost when you're using Greengrass. So just to give you some idea as we're heading out, because we're at the end of our time here, I'm going to give you some idea of some of the customers that are using this. Enel Energy, Rio Tinto is a big mining company, Qualcomm, Intel, I know you've heard of those guys. Here's some of the customers that are using this, and maybe more interestingly, I wanted to talk about the partner network. These are some of the companies that we have working with us on AWS IoT. I wanted to call out in particular C3 IoT is the world's largest IoT platform built on AWS. And lastly, I wanted to get here to talk about all the devices that are out there that are compatible with AWS IoT. So we have devices from BeagleBone, Dragonboard. I've used the Dragonboard 410C. It works great. We've got devices from Microchip. That one there in the bottom is the one that you saw earlier that's pre-provisioned. We have devices from Broadcom, several others. Seed Studio is doing a great job in introducing people to Amazon IoT and selling devices that hook up to our IoT service.